Okay, so first let's take a look at this problem for a little bit, then we'll get cracking at it. So we're given information about two different hypercubes. The first is a p-dimensional hypercube with each value for each dimension ranging from -1 to 1. And then we're given another p-dimensional hypercube here, except the values range from -r to r, where r is less than 1. So we basically have this smaller hypercube, hr to the p, inside of a bigger hypercube, which is h1 to the p. And we're being told that we're drawing two p-dimensional points that are uniformly at random from this hypercube. So now we're being asked of the probability that one of these points is not in the smaller hypercube. So again, because the point is taken totally at random from the big hypercube, h1 to the p, we can solve this using volumes. So the probability of an event not being in hr to the p is equal to the volume of the portion of the hypercube h1 to the p that isn't in hr to the p divided by the volume of the hypercube h1 to the p. So this is just saying this is the proportion of the volume of the bigger hypercube that is not also inside of the smaller hypercube. So what percentage of the bigger hypercube is not in that smaller hypercube? And as it happens, the volume of that portion of the hypercube is equal to the volume of the big hypercube minus the smaller hypercube, which is equal to 2 to the p minus 2r to the p. And we divide this by the value of the big hypercube, which is 2 to the p. And this is equal to 1 minus r to the p. So we can say that the answer to the first part is 1 minus r to the p. That's the probability of the event A not being in h of r to the p. Now we're being asked the second question, what is the r value for which the probability that A is not in hr to the p is equal to 90% as a function of p. So now we just take that value we got from the first question of 1 minus r to the p, because that's the probability A is not in hr to the p, and we set it equal to 0.9. So then we get r to the p is equal to 0.1. P times natural log of r is equal to natural log of 0.1. Natural log of r is equal to 1 over p times natural log of 0.1. And finally, r is equal to e to the 1 over p times natural log of 0.1, which again we can rewrite as saying this is e to the natural log of 0.1 times 1 over p, which itself is equal to 0.1 to the 1 over p. So that's the answer. The answer is 0.1 to the 1 over p value. I hope that helps.